On June 30, 1908, at approximately 7:17 a.m., a cataclysmic event shook the remote forests of Siberia, near the Podkamenia Tunguska River. Witnesses described a blinding light streaking across the sky, followed by a deafening explosion that flattened an estimated 80 million trees across 800 square miles. The shockwave was so powerful that it knocked people off their feet hundreds of miles away, shattered windows, and was recorded by seismic stations across Europe and Asia. The event, now known as the Tunguska event, remains one of the most enigmatic and debated occurrences in modern history. What caused this colossal explosion? Was it a meteor, a comet, or something even more extraordinary? Over a century later, the Tunguska event continues to captivate scientists, conspiracy theorists, and the curious alike. The most widely accepted explanation is that the Tunguska event was caused by a meteoroid or comet entering Earth's atmosphere. Scientists estimate that the object, likely between 50 to 200 feet in diameter, entered the atmosphere at a speed of around 33,500 miles per hour. As it descended, the intense heat and pressure caused it to explode approximately 3 to 6 miles above the Earth's surface. This airburst released energy equivalent to 10 to 15 megatons of TNT, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. The explosion generated a massive shockwave that leveled the forest but left no crater, as the object disintegrated before it could impact the ground. This theory is supported by the radial pattern of flattened trees, the absence of a crater, and the lack of significant meteorite fragments in the area. However, the absence of definitive evidence, such as a large impact crater or substantial meteorite debris, has fueled alternative theories. Some researchers have proposed that the object was not a stony meteorite but a comet composed primarily of ice and dust. Comets, which are less dense than asteroids, could explode more easily in the atmosphere, leaving little to no trace. This would explain the lack of debris and the absence of a crater. Yet, even this theory has its skeptics, as no conclusive evidence of cometary material has been found at the site. The mystery deepens when we consider the eyewitness accounts from the time. Local Evenki tribe people reported seeing a fireball streaking across the sky, followed by a series of thunderous explosions. Some described the sky as being split in two, and the ground shaking violently. One witness, S. Semenov, who was about 40 miles from the epicenter, recounted feeling intense heat and being thrown several feet by the shockwave. These accounts align with the characteristics of a meteoroid airburst, but they have also been interpreted in more speculative ways. One such interpretation is the idea that the Tunguska event was caused by a UFO, an extraterrestrial spacecraft. Proponents of this theory point to the lack of a crater and the unusual patterns of destruction as evidence of advanced technology. They suggest that an alien craft, perhaps experiencing a malfunction, exploded in the atmosphere, causing the devastation. While this theory is intriguing, it lacks scientific evidence. No fragments of extraterrestrial origin have been found, and the idea remains firmly in the realm of speculation. Another far-fetched but fascinating theory involves time travel. Some have suggested that the Tunguska event was the result of a time-traveling object, perhaps a device or probe from the future, malfunctioning and exploding upon arrival. This theory is rooted more in science fiction than in science, as there is no empirical evidence to support the existence of time travel or advanced future technology. Still, it highlights the enduring allure of the Tunguska event as a canvas for imaginative speculation. In the decades following the event, numerous scientific expeditions were launched to uncover the truth. The first major expedition, led by Russian mineralogist Leonid Kulik in 1927, aimed to locate the impact site and collect evidence. Kulik and his team were stunned to find no crater, only a vast area of flattened trees radiating outward from a central point. They also discovered small, glassy spheres in the soil, which were later determined to be microscopic particles of silicate and magnetite, likely remnants of the disintegrated object. These findings supported the meteoroid theory but did not provide conclusive proof. Later expeditions, equipped with more advanced technology, continued to investigate the site. In the 1960s, researchers discovered that the soil and trees in the area contained elevated levels of iridium, a rare element often associated with extraterrestrial objects. This discovery further bolstered the meteoroid hypothesis. However, the absence of larger fragments or a definitive impact site kept the door open for alternative explanations. In recent years, scientists have turned to computer simulations to better understand the Tunguska event. These simulations suggest that the object likely entered the atmosphere at a shallow angle, causing it to explode in mid-air rather than striking the ground. The simulations also indicate that the object was composed of relatively fragile material, such as a stony asteroid or a comet, which would explain its disintegration. While these findings align with the meteoroid theory, they do not entirely rule out other possibilities. One of the most compelling aspects of the Tunguska event is its rarity. Events of this magnitude are estimated to occur only once every few hundred years. In 2013, a much smaller but similarly dramatic event occurred in Chelyabinsk, Russia, when a 65-foot wide meteoroid exploded in the atmosphere, releasing energy equivalent to 500 kilotons of TNT. The Chelyabinsk event provided valuable insights into the effects of airbursts and reinforced the plausibility of the meteoroid explanation for Tunguska. However, it also served as a stark reminder of the potential dangers posed by near-Earth objects. Despite the overwhelming evidence supporting the meteoroid theory, the Tunguska event continues to inspire speculation and debate. The lack of a definitive answer has allowed it to become a cultural touchstone, appearing in literature, film, and conspiracy theories. It serves as a reminder of the vastness of the universe and the limits of our understanding. While we may never know with absolute certainty what caused the Tunguska event, the search for answers has driven scientific progress and expanded our knowledge of the cosmos. The Tunguska event has also had a significant impact on the field of planetary defense. The realization that a relatively small object could cause such widespread devastation has spurred efforts to detect and track near-Earth objects, NEOs. Organizations like NASA's Planetary Defense Coordination Office, PDCO, and the European Space Agency's ESA Space Situational Awareness Program have been established to monitor potential threats from space. The Chelyabinsk event in 2013 underscored the importance of these efforts, as it demonstrated that even smaller objects can cause significant damage if they explode in the atmosphere. In addition to its scientific implications, the Tunguska event has also captured the public's imagination. It has been the subject of numerous books, documentaries, and films, each offering its own interpretation of what might have happened. From speculative fiction to rigorous scientific analysis, the event has become a symbol of humanity's fascination with the unknown. It serves as a reminder that, despite our advances in science and technology, there are still phenomena that defy easy explanation. The Tunguska event also highlights the importance of interdisciplinary research. Understanding such a complex event requires expertise from a wide range of fields, including astronomy, geology, physics, and even history. By bringing together researchers from different disciplines, we can gain a more comprehensive understanding of what happened and why. This collaborative approach is essential for tackling other scientific mysteries and for addressing the challenges posed by potential future impacts. Moreover, the Tunguska event has implications for our understanding of the history of life on Earth. While the event itself was relatively small in the grand scheme of things, it serves as a reminder of the role that cosmic impacts have played in shaping our planet's history. The most famous example is the asteroid impact that contributed to the extinction of the dinosaurs 66 million years ago. By studying events like Tunguska, scientists can gain insights into the processes that have shaped our planet and the life it supports. In the end, the most plausible explanation remains a meteoroid or comet. Scientific evidence, such as the radial pattern of destruction and the presence of microscopic extraterrestrial particles, strongly supports a natural, albeit extraordinary, event. The absence of a crater and debris suggests the object disintegrated before reaching the ground. Eyewitness accounts describe a blinding flash and a deafening boom, consistent with an airburst. While alternative theories involving UFOs or time travel spark fascination, they lack the scientific backing required to be considered seriously. The Tunguska event serves as a reminder of the immense forces at play in our universe. It demonstrates how even a single cosmic event can have profound effects on our planet, altering landscapes and igniting curiosity about the unknown. As research continues, scientists strive to unravel the mysteries of celestial impacts and their role in shaping Earth's history. The Tunguska explosion provides valuable insight into planetary defense, reinforcing the need to monitor near-Earth objects that could pose similar threats. The event remains a subject of intrigue, inspiring scientific studies and imaginative storytelling alike. While a meteoroid or comet remains the most likely cause, the lack of definitive evidence leaves room for speculation, fueling debates and theories ranging from antimatter explosions to undiscovered natural phenomena. Even with modern advancements, the Tunguska event reminds us that our planet exists within a vast and dynamic universe, where unforeseen cosmic events can occur at any time. It underscores the importance of scientific exploration and preparedness for potential future encounters with celestial bodies. So, What truly caused the Tunguska event? The evidence strongly suggests a meteoroid or comet, yet the mystery persists, inviting us to keep questioning and discovering. In the end, it is this pursuit of knowledge that drives both science and human imagination forward.